similar to most scripting languages and things. Hi, thanks for the subscribe there, Grimmanity. So tonight's a different stream, something a little different. Majority of the time it's try hack me and talking about pen testing and taking the CTF world and kind of showing, talking about real life stories about pen testing. But tonight I wanted to talk more about how infrastructure as code can help you as a pen tester, red teamer, and make it easier for you to deploy infrastructure in any of the cloud providers. And so um, I've been using Terraform for quite a bit now, and it's gone through some iterations and stuff like that. But one of the big things that I ran into a majority of the time is when you're learning something new, there's almost never enough examples, and there's never enough examples that actually work. So you might read an article from a couple years ago that someone did something, and you go do it, and it doesn't work anymore, or the thing that they're trying to do is not compiling correctly, or scripts doesn't work because that library is not valid. Um, but I wanted to introduce Terraform to the masses because I think this is a technology that it's growing a lot, but it's a technology that helps people achieve things quickly and easily, and it's pretty easy to understand. It's similar to most scripting languages and things like that. All right. So if you're new to the stream or if you've been around, watched a couple of my streams, I'm Tobias. I'm a Nova Hacker Ambassador. Was an Air Force veteran for 10 years. I was in the Air Force for 10 years. Now I'm an Air Force veteran. I've been doing information security for about 15 years. I mostly do pen testing and infrastructure as code and automation. So usually I find problems and then I fix them um, in an organization, or I make it so that it's easier to do things quicker. And I think that's just a value add. Um, that QR code goes to my link tree, which then has GitHub, Medium articles, and things like that. And some of my other dev streams, my last one was about um, how you could create a self-deployment portal, which uses some of this Terraform and Rundeck and Guacamole to basically spin up a cloud infrastructure and um, have you have a portal to your infrastructure without having to worry about you know uh, SSH keys or usernames or passwords or anything like that. And it's something that as a team, if you needed that, you could use that and stuff. So I hope that helps out. But this tonight is kind of giving you more of that example code to kind of build on that. The example that I ended up using for the self-deployment portal was just Google. And so now we're kind of diving into kind of the four major cloud providers now: Azure, AWS, Google, and DigitalOcean. And to when you're deploying Terraform, each cloud provider kind of they want you to request a resource in a certain way, but they all kind of have a consistency between them too. And so when we go through the code, you'll kind of see this that each provider, a machine resource is going to consist of an image. So we have to know what we're going to actually boot up, and that's usually like Ubuntu, Kali, CentOS, or it can be an image that you built, like an AMI for Amazon or a Google image. You're going to need to define some kind of storage on the system. It's got to save this data somewhere, and then a firewall or a security group, and that's telling the resource what ports you want to allow in or out, and then an authentication method. How are you going to log in? How's that username, password, SSH? LDAP, some other mechanism, SSO, things like that. So that's it for the slides, really. I wasn't going to get much into that. I really wanted to show more off the code, explain some of the code and the ideas behind it. All right. So the way that I liked to kind of when I'm developing Terraform is I usually develop in kind of modules, and there's a module registry that can help you out with some of these things. But the code that I have is kind of you end up reusing your code majority of the time. Um, these examples were to deploy Hak5's C2, and there'd be an episode on Hak5 that kind of sums up everything here, and I just wanted to show off more in depth of what exactly that entailed and stuff. But Terraform, again, like I said, is very easily scriptable and is an easy language to understand. So what I have in the repo and what you'll see is each cloud provider's broken down: AWS, Azure, DigitalOcean, Google. I even included a Docker image in case you wanted that. And then each one of those cloud providers has a README, and the README kind of talks you through some of the instructions on how to sign up for an account, how to configure it to work with Terraform, if you need any tools, and then what you need to kind of do specifically for that cloud provider. And again, this is kind of trying to get people into using these resources quickly and easily and in a manner that you can do it repeatedly. And once you set up your dev environment to do Terraform, I kind of more suggest kind of sticking on that box. So like I have a dedicated host that I put my Terraform code on and I deploy from. And so this already has my AWS set up, my Azure set up, my DigitalOcean stuff set up, and my Google set up. Once you have everything written out and everything's in Terraform code, all you have to do is go to that directory, and then if you do a Terraform init and a Terraform apply, and then that takes those instructions and it says, okay, we want you know this is what the user's defining as a cloud resource, what it should look like, and it does all the API keys, all the API functions in the background without you having to know all that type of stuff, without you having to script that all out. And so I kind of talk some about the limitations and some of the things for the Hak5 C2. You had the ability to kind of do HTTPS, but it had to be, you had to have a DNS name. And so all the cloud providers don't provide DNS except for Amazon. Amazon will give you a DNS name for your EC2 instance right when you spin it up. For the other cloud providers, you kind of have to bring your own DNS and reassign that. And you can do that in Terraform too. There are ways to update your DNS record on the fly as you're doing this with Terraform. Um, I didn't I didn't put that into the code because again it's something that is not needed unless you need it. So it's something that the user kind of has to add, and then some limitations and things like that. Yeah. And again, this was just more kind of cloud C2 specific. But so this is the README for AWS, and then for the actual code, Terraform starts at the main directory and looks for anything with a TF file. And then based on that TF file, so we're in the AWS directory, it then breaks down if it needs to go into other directories and load in those other resources. So you literally just read it from top down. So the first thing is we're calling a module, and anytime you see the first word, it's kind of a keyword, and then it's whatever you're naming it. So in this instance, the module I'm just naming it create VPC, and then this is going to dive into the modules AWS and create VPC. So you just follow the directory tree: modules AWS create VPC. And once it gets to that directory, what it's doing then is it's looking for, again, Terraform files. And so if we go into the main Terraform file, this is all already set up for you. You don't even have to edit anything. This already sets up what is basically doing is creating a VPC for you, and it's the CIDR blocks, there's the subnet. You can set up the internet gateway and tie it to the internet gateway, your routing table, and then routing table associations. And you could change this if you needed to, like if you had to have different CIDR blocks for whatever reason. But majority of this code for beginners, this is not needed. And then output, this is taking that information and then providing it back to the module to use. And then variables, again, is just a way to kind of make things callable from certain other things. And so that's it. Like again, this is pretty easy, pretty readable. So then we move on to our next section here, and now we're looking at modules AWS Hak5 C2. So if we go into that main folder, here's that machine resource what we were talking about before. And so we need to provide we have to have a provider. So in Terraform there are multiple providers, and we'll see that as we go through these. But in this case, we're using the AWS provider. It needs to have a region to know to which region to talk to, and it can pull this data from the AWS region, and it just pulls the current. So this is kind of also signing it. Uh, Again, we talked about authentication is needed for a resource, and that's what we're assigning here. The resource, we're assigning an AWS pair, a key pair, and we're naming it Hak5 C2. We provided a key name and then to read that file. So it's you generate your own SSH keys, and as long as it has that file name, it's going to read those in. It's going to provide that public key to Amazon automatically, and then use that to basically sign into the instance once it's spun up. Then we're calling in, we're specifying an AMI and an instant type. There's the key name, which is what we got from up here. VPC, which we looked at earlier, subnet ID, which we looked at earlier, and then telling it that we want to associate a public IP address. The next portion of this code is a provisioner. So this is telling Terraform to do something, and we're provisioning a file. And so what we're doing here is all the files that you put in this files directory will get uploaded from your system to your EC2 instance that gets spun up. And this is just a way to kind of provide you an easy mechanism to transfer files without having to SCP them over. And then we're performing an executioner. So again, we have another provisioner. We're doing a remote execution. So we're performing this on the host, and then you're writing whatever commands that you want to execute on that host. And so, for the Hak5 C2, I'm just updating the repos. I'm installing unzip, wget screen, and then making a directory, pulling the Hak5 C2 binary down and unzipping it. And that's it. And all it needs is to provide a connection detail to that. So it performs all that stuff on the server for you. Then we have some outputs. Again, this is when you get done with the Terraform, it spits out these things: IP address and DNS name, and then security groups. So we talked about firewalls, and this is where you're setting up those firewalls. If we go back to the main file right here, we can see that we are calling this security group right here, AWS security group. And so again, it's able to pull this information and do what they call inference and put this information in there so that, again, you don't need to do this. For what I'm providing here is that you can specify whatever ports you want to open. And we can see this here. This is a variable ports. And so if we look at variables, I just want to kind of show all this stuff. We see here's ports is a variable. And I'm only calling 80 and 22. And so this information goes into this Hak5 C2 portion and then gets put into basically the security groups. And we're able to dynamically create an ingress rule for each one of those ports because it's in like an array. And based on the information in that array, we're saying for that content, create a a from port line, and that's the ingress value, which is this is ingress, and then whatever that value is, to another ingress value, protocol TCP, and then we're specifying basically all CIDR blocks. And you could change this to whatever you want. You could also do this same thing with your SSH port. Yeah, it's more highly recommended that you make it so that your SSH rule is more directly from your like your public facing IP or things like that from like your home IP address if you're building a lab or if you have a network block that your company comes out of. That's where you want that SSH port, and then it just kind of stops everything on the internet hitting your SSH port. But for this portion right here, the dynamic ingress, we want to be able to access this from wherever, due to callbacks and things like that. And then egress needs to be specified, and this is again something specific to kind of Amazon that you have to specify what ports you want out, and we're just basically saying from port 0 to port 0, allow all, and for Amazon, all is -1, and then to every CIDR block. All right, so now we've built our EC2 instance and everything's there, but um, when you run commands, we were running an unzip command here, and it basically put that binary on the system, and that's great. But in some instances, when you're running a command, you kind of need to provide it a bunch of like variables and things like that. And and so the easiest way I found to do that is calling a null resource. And so that's what I'm doing in the next section here for this module C2 run is I'm saying, okay, load up modules null resource. So if we go to null resource, we're gonna we're gonna create a connection back to that EC2 instance, and now I'm again running a remote execution, but we can see that I'm specifying on the command line some kind of these variables, the host name and listening port from before. And that's just so that we can pass these on either through modules or through specifying this directly, um, and just giving that command a way to do that. And doing it via null resource just make sure that it happens after everything's all set up. And then for AWS, we're putting an output for the C2 output and the DNS output. So pretty easy, pretty simple. Um, and I just want to kind of show the examples of each one of these cloud providers as we're going on. So we'll close all those up, and we'll look at Azure real quick. So same thing, you'll kind of notice there's a lot of similar structure to each one of these, and that's again trying to get everyone into that idea of keeping the same, your code the same, so people can read it, and then other people on your team can provide maybe feedback or anything like that. So here's the main folder for Azure. We're again specifying read the modules Azure Hak5 C2. So Azure Hak5 C2 main. And you'll notice this is there's a lot more involved with Azure here compared to AWS. And like that's what I was trying to say with each cloud provider, they want you to do it a certain way. They want you to spin up certain resources and then attach those resources to your machine. And it's hard to find example code to show you this because for the example code for Terraform, it just says, here's a resource, this is it. Like this is the sample code that you get for creating a virtual network. So you kind of have to tie all these pieces together almost by yourself a little bit. And that's what I'm kind of giving out is basically showing you how to do this in an easy fashion. And again, if you're doing this with some other infrastructure, if you don't want to name it Hak5, you could name this anything you want. It's just the way that I was naming it for the task that I'm trying to do. So again, like I said, Azure has a lot more involved. They have a virtual network. You got to define a subnet. You got to define a public network. There's your network interface. So you have to specify a network interface for it to use, and then you have to specify a network interface internal. Then your security groups. We're down to security groups now, um, and these all tie back into each other. And we can see that for Azure, this was the thing that got me with creating security groups. Um, you'll notice what I did with AWS is I was able to define dynamic rules. I was able to take a list of IP port numbers and then dynamically generate security rules. With Azure here, um, what they want is a priority assigned to each one of these rules. And so there was no easy way for you to specify a list of ports and then have that assign a priority. So kind of had to do it a different route here, and let me point this out. And these are the kind of gotchas that end up, you know, turning people off sometimes and not understanding how this stuff works. So right here, I'm specifying one listen port, and this is going to get fed back in here, and you see that that's this port right here, is that variable. And so again, you could only specify a port or port range, and that's that doesn't make it easy when you're wanting multiple ports or anything like that. So a user would have to come in here and copy and paste this rule and then change the priority every time. Um, there was just no way that I could figure out to dynamically change that. And if you do, and if you know and you have experience, please submit a pull request, and I'll definitely update the code. So then we have a network group association. I'm using a Linux machine, and I know it's going to blow people's mind that you're using Linux on Azure, but again, this is the way I was comfortable with doing things. And so you call a resource Azure RM Linux virtual machine. You give it a name, and then same thing, size. So each cloud provider has their size nomenclature. And then the funny thing with Azure was that a majority of cloud providers, you can just they they more kind of push you to do an SSH key than a username and password, and that's because again, as soon as this thing's open to the internet, it's just going to get bashed. But Azure lets you kind of specify a username and password. In my case, again, I opted for more security for the user, whoever's deciding to deploy this, and they're going to still do an SSH key. But that's just something to kind of be aware of, is that yes, you could do username and password if that's something you want to do. And so again, we're still in this resource of the Linux machine, and like I said, for each machine image, you need to kind of specify what's your base image. So we're specifying Ubuntu server here, the version, latest. Here's our OS disk, and then now we're starting to do our provisioners. And you'll notice that these are the same provisioners as AWS, and that's because Terraform. This is a Terraform specific thing. A provisioner is a Terraform specific thing. And so we're provisioning a file. We're again copying it from the files directory into the temp directory, and this time all we're doing is changing the user and what key we need to read basically, and then executing the same commands on the server. So for Azure, again, we're just putting out the output, and we specify the variables listen import and SSH C2. So we did the same thing. We bootstrapped it. We downloaded the binary, and then again we'll go back and relog it back into the instance and kick off that job. And what I'm doing is a no hup, and that's because I want to save the output of that file. And I'll show you here in a minute if you never played with the Hak5 C2. All right, so DigitalOcean. And I know it seems a little bit repetitive, and that's kind of thing I want to point out is once you get the hang of each cloud provider, doing something like this in multiple cloud providers is easier. once you kind of have this base code, because now you can just do this for multiple providers and have your infrastructure in multiple areas. So if maybe maybe your organization that you're doing a test against blocks Amazon, well, are they going to block DigitalOcean, Azure, and Google? That this gives you that ability, that flexibility to move around, and you can update that null resource to or the main part of the code to kind of remote execute whatever you want. Um, this could be anything. You could download Beacon or Cobalt Strike or any cool C2 that you wanted to try out and play with. And this gives you a quick way to do this. So for here's DigitalOcean. DigitalOcean again, it kind of reads a creds file. This was the only provider that I was kind of like, ooh, that's not cool. A majority of providers, they want you to kind of either put your credentials in an export function, like an export from your Linux terminal, or kind of signed on, basically already have it like your authentication tokens in memory a little bit. This one wants to, and again, don't get me wrong, you could actually just put your code into the file too, and I think Google kind of requires that a little bit too. Um, but basically, just reads it straight from that code. And again, you need to protect that code with the highest level that you can, because if someone gets access to that code, they basically have the ability to create resources on your behalf. Um, and so, it's not something you want to just leave lying around. Um, anyways, DigitalOcean, again, we define the SSH key where we're uploading that SSH pub key to DigitalOcean. We define the resource, what droplet that we want. DigitalOcean likes to name their stuff droplets, so we were specifying that's an NYC. This, how big is it, the image, um, and then the SSH keys to use, and then right to a provisioner already. File, remote execute, and then specifying a firewall. Again, DigitalOcean did allow you to do dynamic firewall rules, which is cool. Makes it easier. I'm gonna kick off digital, and here is a word of advice. If you want fast infrastructure, DigitalOcean's apparently it, because um, every one of the cloud providers that I did this for, it will easily take anywhere from like 5 minutes to just spin up one instance. More instances you create at the same time, the more time it takes. But DigitalOcean will be done in like 3 minutes. And of course, I say this on stream, and it won't be, but you know, demo fail. So I'm in the DigitalOcean directory. You can see that I just wrote Terraform apply. This is telling Terraform to read all the Terraform scripts, come up with a plan on how to deploy this, and then apply that plan. And then what it usually does is just shows you the plan and asks you, do you want to accept it? In this case, I'm just saying approve it. I already seen this plan so many times, I know what it's doing. So we can see it created the Hak5 key. It's done in 2 seconds. Now it's creating the C2, and then once this instance, this droplet spun up, it's going to provision the file and then copy the whatever I have in the files directory, which is nothing. It's already so this it's already spun up, and now it's already installing the packages. That's how quick this is. And we'll give it like 3 more seconds, and it'll be done. So now it's doing the remote execute. This is the null resource provider. So again, we're in here. We're waiting to execute that no hup. Here's the IP address. Here, it's saying that it's logging in with the root, and then that it used the SSH key, private key here. It connected to the port. It's waiting to execute that command, and once that command basically gets background, it's done. And that's it. It's already done. So if you were to actually go to this IP address, So if you go to this IP address right now, that instance is already spun up, ready to go. And that's how fast it was for DigitalOcean. Again, like the other ones I said, will take a while. So the cool thing about Hak5 Cloud C2 is that it requires that you have a license key and a token to finish the setup. So you couldn't do anything on this instance right now. Um, One, you don't have the license key, even if I gave you the token, which the token in this case is in that no hub files, and we can SSH and I can show it to you. So if we SSH root, we're pulling that IP address there, and then because we're using SSH keys, do -I SSH keys and do keys, and we're logged into that. So for the Hak5 stuff, I created a directory called Hak5. I think I need to do, no, I am root, so cat and no hub. And so the no hub kind of just saves that output there. So again, there's the setup token. This gets randomly generated every time. And that was really smart of Hak5 to do that. You still need a license key to even set up this instance, which good luck, because as quick as it's been applied, so can it be destroyed. So now this is again reading the Terraform state, and then going ahead and applying all those API keys to destroy all that interface. It's destroying the key, it's destroying the C2 instance, the firewall rules, and within the next 60 seconds or less, it'll be done. There it is, all done. So if you try to go to that IP address right now, it's not even live anymore. All right, so the last cloud provider I want to go over was Google, and Google's an interesting one. So you have to create a project first. I think you can only have one project per your Google account, and whatever that project name is, you kind of have to get and put into this project field. And again, I've tried to make this as transparent and easy for people to do this. So you would have to replace this project code here. Uh, the project code that I have is not going to work for you. This is only assigned to my resource, to my availability. So you put that in there, and then again, it's the same type of stuff as everything else. It has modules, it has a Google, and then same thing. Again, we're specifying the project. You have to get the credentials for that project, and then moving forward from there, it's going to create the resources, create the instance, assign it what type of machine that you want. Here's your image. This one's using Debian Cloud. Google has a lot different images, so this one just seemed to work that I was testing a little bit. Um, and again, the way that they refer to their network interfaces and pulling those IP addresses is different than most of the other cloud providers too. Um, and so we're pulling the NAT IP as they call it, and these network interfaces, again, it's kind of like if you ever done Python and try to access an array. So we're accessing the zero interface and the zero access config. And so if you didn't add another one and you try to do one, it's not going to find it. And that's the funny part about some of this is that the way that they kind of refer to their interfaces and things is a little bit different. So then there's our firewall C2 and the HTTP firewall, and same thing with the null resource. So we're just creating that null resource again, and to execute the no hub. So that's kind of what I wanted to show off. This is live on my GitHub account currently, so you can go to that. Again, if you needed that link, here's the link to my link tree, and if you click the GitHub button, that'll send you to the code. And this is called Hak5 C2 deployment. And again, the idea is to get people more interested in this infrastructure as code. As you can see on the stream, it was pretty easy to read this. As you progress and people need more different types of resources, you can start adding to that, and everything's documented then. So you can easily read that code and say, okay, I know what ports are open. I know what size of my resource is going to be. I know, so you can estimate cost and things like that. Um, so that's kind of leading, pen testers and red teamers in this direction. And there's a lot of people that use Terraform as it is. Chris Trusser, Rasta Mouse. These guys kind of led the way on some of this stuff. And I'm just trying to provide it so it's more easier, I guess, to kind of everyone start looking at this and start getting more into it and getting more used to this type of stuff, because that's that's where our industry I think needs to go, and the development industry is already going that way, so we need to, as pen testers, understand this better too. So that's all I